be here and to be able to talk for February's speaker list. It is an area where I'm very passionate about. And it's interesting because as soon as you bring up system of systems, doesn't matter what topic on system of systems, what I found is that a lot of people have a lot of different opinions on this. And it really does help to offer at least some definitions so that we are all baselined in what we're talking about. So about 5 years ago, I began, actually, I should say this, about 10 years ago, I started seriously considering doing some research into the concept of a system of systems architecture framework. And the reason why my interest was piqued was because I actually use the very common architecture frameworks that are available today: DODAF, the DoD architecture framework; MODAF, the Unified Architecture Framework; FEAF, the Federal Enterprise Architecture Framework, and a host of others. And what I found was it is very challenging, if not downright impossible, to represent a true system of systems with certain characteristics using those architecture frameworks. So when I started thinking about this, again, it was about 10 years ago, and then I got very serious on my research about 5 years ago. I contacted some of the architecture framework authors and others that are involved. All right. And I asked them, hey, I'm interested in doing some research on developing what is needed to represent a true system of systems in an architecture forum. And your framework, I've noticed some challenges. Why I got a lot of different responses from, I don't know what you're talking about. You can represent any system of systems architecture in DODAF. I got that. I also got a response from one person involved in FEAF, and it was the same response. I don't know what you're talking about. You can represent a system of systems using FEAF. And I'm thinking, well, maybe your work is different than mine because I'm really having some challenges here. So a lot of various opinions. And so when I started doing my research, and in full transparency, this eventually became my dissertation topic. And when I presented this dissertation topic to my university advisors at George Washington University, where I received my degree, I got a lot of similar comments, and they were like, "Well, if you want to do this, you're going to have to show me that a system of systems architecture framework is needed. Why not? Why can't you use DODAP or FEAF or any of the other architecture frameworks out there?" And so they really did give me some big challenges on this, and said, no, we're not going to let you write a dissertation developing an architecture framework because you're going to have to prove first that you can't do what you say you want to do with what is out there today. So I did. I went through and I started delineating the reasons, the differences. Why is DODAP? And when I say DODAP, I'm talking about version 2.02. And by the way, let me pause here. I realize that all architecture frameworks are continuously being updated, and of course, new versions are being released. So I obviously have to baseline my research. Certainly, I did that for my dissertation. So DODAP 2.02 was my baseline. And now, though, I'm going to continue my research, and I will be using the latest and greatest architecture framework. So that aside, just wanted to bring that out. So there was a big challenge for me. So let me get into some of the work that I did. This is not just a regurgitation of my dissertation. I've actually added a number of things here as well to kind of bring at least you up to date with what I've been doing in this area. Before I do, though, some background. What has amazed me, and I have really kept up with a lot of the work being done in System of Systems. I don't know if you can see it, but I've got, a library behind me. You probably, if you can't read the titles, every time there is a technical book related to System of Systems engineering, I get it. I put it on my shelf, and I actually read it because I want to stay current with that. And so there's been a lot of, I'll say a flurry of books on or things related to System of Systems engineering in the last 5 to 7 years. It's very interesting. In the first decade of this century, 2000 or 2001 to 2009, 2010, there was a flurry of books. There were about, 8 or so books that came out. Mohammed Jamshidi was one of the principal authors for several of those books, and he is still involved in the field today, and I do appreciate that. My favorite book is his System of Systems Engineering book that he was the principal editor in 2009. I honestly wish he would put out a second edition to that book, but to no avail. So what's happened though is System of Systems has gone through a lot of definitions. You'll see a lot. I mean, every textbook, every article has something similar. And I've reproduced Jamshidi's definition here, but they're not exact. There is no one definition that's acceptable across the community. What is largely accepted are the characteristics or attributes, which is amazing. Of the 7 attributes that I list here, the first 5 were introduced by Mark Mayer in the 1990s in his Systems Engineering Journal article. And they have not changed significantly in over 25 years. They still are at least a part of a set or the set of characteristics. Now, I've added 2 from some other authors' work, self-organization and adaptation. But in fact, these 7 have stood the test of time. So I'm just amazed at that. The concept of understanding what is a system of systems, at least from its characteristics, has stayed relatively stable over 25 years. So that helps me a great deal, obviously, because I'm going to use this information in how to describe a system of systems and ultimately to understand what's needed to be able to have or obtain an architecture framework for that. Before I dive in, though, to the work and the research that I've done, I did want to take another step back. So here are the definition / attributes. I also wanted to talk about what do I mean by an architecture framework. Some of you may not be familiar with what I'm really referring to when I say architecture framework. So let me just give a short tutorial. Please bear with me, those of you that are knowledgeable in this area. This applies to all levels of systems engineering, not just System of Systems. In the upper left-hand corner, I could easily have said the system, or the system of system, or an organization, etc., at all levels. So let me just take it for a single system here, but again, you can substitute SOS, System of Systems. So a system has an architecture. In fact, we develop an architecture when we are going through the system development lifecycle. In years past, before the A word, architecture, was accepted, and I'll leave it up to you to decide whether the word architecture is a good word or a bad word. It sort of depends, all right? But we develop system architectures. And in fact, we call that systems architecting. In times past, before the A word was part of our regular knowledge, we usually called these conceptual designs or even preliminary designs. But architectures were broader, higher level than ultimately the detailed design of a system. So I'm talking typically early in the development lifecycle. Of course, the system has many stakeholders which are going to influence its development. So where does architecture and architecture frameworks and all that come into play? Well, when we talk about an architecture, especially in the 1990s, but some preliminary work happened even earlier than that in the development of architecture frameworks, we started to formalize architectures, because before there were formal frameworks available, any engineer developing a system would, in essence, use their own or maybe their company or their customers' constructs. And so there was no standardization. U.S. Department of Defense and the United Kingdom's Department or Ministry of Defense, they led an effort on the commercial side. The Open Group began looking into formal constructs. So a lot of work was done again in the late 80s and 90s on this area. So eventually, the concept of an architecture consists of different perspectives onto the system, and these perspectives were typically given the name viewpoint. In my mind, the two words are synonymous: perspective and viewpoint. And then within a viewpoint or perspective, there are typically many different architecture views. These views can be a series of models. They can, and both literally meaning a software model, or they can be a diagram on a piece of paper, or they can be a table of data. So views is a very broad term, but the viewpoints as defined will typically contain many architecture views. So you can see a hierarchy here. An architecture has different perspectives or viewpoints. Each viewpoint has multiple views. And so the formality came into play when architecture frameworks were developed. And the idea here is that an architecture will conform or should conform or may be mandated to conform to an architecture framework. There are many, by the way. In my research, I was able to identify over 150 architecture frameworks that have been documented somewhere in the literature and open sources, excuse me. So what does an architecture framework do? It does a lot of things. Among them, it defines what these perspectives are, these viewpoints, and it defines a set of different views or models or representations. As I mentioned, each view then can conform to a particular modeling language. So we have a lot of modeling languages out there. Two examples are the Unified Modeling Language, UML, and then the second example is something that most or many of us deal with, and that is the Systems Modeling Language, or SysML. And so that's where modeling languages come into play. So what is common is that you'll see one of the more accepted architecture frameworks being used, especially dealing with government development projects. And a common modeling language is SysML. But keep in mind, you're typically not restricted. If I'm going to use UAF, the Unified Architecture Framework, for example, then I'm not restricted to only using the modeling descriptions in SysML. I can use others as well. But throughout all this now, we have formality. Now, one of the things that architecture frameworks and the developers of those frameworks realized is that it's not the core is not the models themselves. The core is the underlying data that feeds or operates in and on these models. So I can define all kinds of fancy frameworks, viewpoints, views. I can define modeling languages until the cows come home. But what makes a good architecture is the data that is behind it, the foundation. And I'm really thrilled to see that in the last 10 to 15 years, as frameworks have evolved, they've recognized this. So kudos to that. All right, all that. So that's a tutorial. That's the end of my tutorial part on what is an architecture framework and how it is involved in developing a system. So now let me start focusing on some of my research that I did. So first of all, what is always good before you start research is identifying what the problem is. And so to me, the problem is that there is no system of systems architecture framework defined. When I did my research, I could not find any common general system of systems architecture framework. I also looked did someone provide extensions? Like, is there an extension to DODAF somewhere, or UAF, or FEAF? Pick your favorite acronym. And what I found was that there were some extensions, but they were usually domain specific. And I'll talk about that in a little bit. All right. And so, like I said, when I did some research, I found over 150 architecture frameworks that are documented and out there today. But of all of those 150 plus, there are none that are exclusively or specific to architecting a system of systems. All right, so fair enough. Again, my advisors, when I presented this as a research topic for a dissertation, my advisors challenged me and said, well, wait a minute. You got to tell me, you got to convince me that what is out there today cannot do the trick. All right. So I went about doing that. We're all familiar with some of the more common architecture frameworks. Of course, the granddaddy of them all is the Zachman framework, which was actually way back. He published a paper, an internal IBM paper. Oh boy, decades ago. I don't even want to venture what the date was of his original paper. Eventually, of course, Zachman founded an institute, which you can look it up. You can Google the Zachman Institute. Very interesting. And so they put together a really nice framework here. It was primarily focused at the enterprise level. And then there's a whole host of examples. I'm using one, DODAF, that looked at frameworks that focused on the system level. And of course, all these have evolved and new frameworks have come up. And again, the numbers are staggering that have occurred. But by the early part of this century, and between that first decade, between 2001, 2010, most of the prominent frameworks were established. And now it's more of an evolution process. And I'm sorry if I don't have your favorite architecture framework. These are just examples. And so what I needed to do was to take these collections of frameworks and ask, well, can any of them properly represent system of systems given those characteristics that we just saw that have been stable over time? So I started asking a couple of questions, and these were my research or study questions. And I'm going to answer these questions by my last slide has the answers to these questions. All right. And again, I do apologize. Obviously, we're restricted on time, but I'm willing to follow up with anyone who is interested in doing that, including if you're insane enough to want a copy of my dissertation work, you can. I'll be more than happy. It is public domain. All dissertations are public domain, as I understand it. So first question that I had to answer was, do they exist? Are there any out there? First of all, is there a system? So I already mentioned when I researched, I found over 100. None of them are true system of systems architecture frameworks. But what I did find were there are a lot of domain specific system of systems architecture frameworks. I offer two here. One is from the Department of Energy. The other is from the Department of Homeland Health and Human Services. And I just give I took a single diagram to represent them. Very interesting. And they're documented. These, of course, if you look at these, they're very similar to enterprise level architecture frameworks, but they've got a lot of good features to get at um, these characteristics that I had mentioned. So, in other words, the framework was developed in order to create an architecture for the problem at hand, whether it was a smart grid architecture, which is represented on the left, or a healthcare delivery architecture, which is the example on the right. And what was found when I peeled the onion back and I'm asking the question, well, wait a minute, you created your own architecture framework? And when I started talking to some of these authors, they said, yeah, because a system of systems architecture, it doesn't exist. And the enterprise architectures, FEAF, et cetera, Zachman, they don't give me enough detail. I can't represent some of the nuances, some of the characteristics. So I then continued this and I looked at some other domains. Military, of course. Military has a lot of examples. Although in the military, they are typically restricted to DODAF if you're in the US, or MODAF or UAF if you're dealing with other countries' militaries. And so I started collecting all of these domain specific architecture frameworks. And yeah, they basically, I mean, almost very clearly, they were system of systems levels. And I started to dive into them. And I thought, okay, well, what are the common elements? If the Department of Energy had to develop their own architecture framework, they couldn't use DODAF or FEAF or TOGAF or UAF. They developed their own. Or if the healthcare domain, in this case, Health and Human Services, again, they had to develop their own architecture framework, similar to what exists, but not exact. So if I started collecting these, and I did, what were the common attributes of the framework? And here's what I found. There were 6 common attributes of all of these domain frameworks. And each of these represents issues where they couldn't adequately or sufficiently develop their architecture within one of the known architecture frameworks. One of the biggest was decision making and governance, especially when dealing at the technical level. FEF deals with governance and decision making, but it wasn't the same. It was not really at an operational or technical level. It's much more of an enterprise or organizational level. And so again, these domains ended up creating their own. So what I found is in system of systems, decision making is different than either at organizations or in individual systems. So it's really interesting. Adaptability, adaptive behavior was another area. What most of the big architecture frameworks have are what we call static views. When you get down to the view level and the models that they incorporate, they're static. And architectures using these architecture frameworks tend to be static. Unfortunately, a true system of systems that exhibits the attributes we listed are not static at all. In fact, it's a very dynamic environment. And that's where some of these existing architecture frameworks do not do a great job of representing. So let me give an example. In DODAF, for those of you familiar with DODAF, DODAF has an operational view. And that's a viewpoint, operational viewpoint. And one of those is a resource flow, an OV2. And you can put together a model using a pretty standard process flow type of diagramming technique. The issue, though, is when you put together an OV2 and you have a diagram that represents flow, resource flows within an entity, system of system or a single system, whatever, it's static. In a system of systems that's highly dynamic, the OV2 itself changes with time. So what you find is when I'm developing a system of systems architecture, I can create an OV2. I have, in fact, for DoD, DHS, and DHHS architectures. And I've created OV2s. However, in the system of systems, they're not static. Resource flow is not static. So what I do is when I create an OV2 diagram to represent a view, that's a snapshot. Yes, at one given time, I can describe the resource flow of my system of systems with that diagram. But a day later, it may not be applicable. My resource flow has changed. And I need a whole new OV2. So what I ended up doing in my day job, my work, is I find I have a family of OV2s because depending on the situation, not to mention the evolution of the system of systems, my OV2 changes. I can't give you one OV2 diagram that represents a Homeland Security system of systems. I can't give you one OV2 that represents a healthcare domain situation throughout, a long period of time. I have to start giving you multiple OV2s. Then the question is, well, what causes the system of systems to go from one depiction of resource flow, one OV2, to another? So if I have this family of OV2 diagrams representing sort of like, possible states of the system of systems, well, then I need to take a step back and I need to start asking, well, is this now really a state transition situation with my OV2s? And then I started looking at other views, my SV system views and other views. And I kept running into the same issue. The problem with using static architecture frameworks is that I don't have a static architecture that I can write down or provide one diagram, even if it's perfect. Write down one diagram and say, okay, here's my OV2, or here's my OV5, here's my SV1 or SV2. I can't do that. It changes. It's dynamic. All right. So that's what I came into play. And when I started talking with some of these authors, they told me, yeah, pretty much the dynamic nature is why we had to create our own architecture framework. We couldn't rely on what's out there today. So that was really enlightening to me. When I pulled all those together, I said, okay, well, let's delineate some of these discriminators here and try to get at an understanding, at least between single systems and system of systems. And here's what I came up with. There are certain areas that really need to be focused heavily on when you're engineering a system of systems. Decision-making is one. Activities are the other. If I'm the lead systems engineer of a system, traditional system, I define what actions or activities the system will perform. It's part of my requirements. I have functional requirements that I develop. I'm the chief systems engineer. And then I design the system to be able to conduct or perform those functions, activities, and actions. Well, what happens if those activities change? Does this mean now I need to include every possible action and activity in a system of systems? Well, then we get into a situation where that's not always possible. Systems come together in a system of systems environment, and they interact in ways that we didn't anticipate. And together, they're starting or they actually perform functions and activities that we didn't account for. How can I put that into an architecture? So speaking of interactions, that's another area where it's very hard to represent in static diagrams. Systems interact both with other systems and the environment in a very dynamic way. And it's time dependent. On one day, a system will choose to interact with other systems and its environment in certain ways, but yet so many days later, they may decide, nope, I'm not going to interact with those systems anymore at all, or I'll change the nature of my interactions. How about sharing resources, sharing data and information? Well, if individual systems are independent or semi-independent, which we assume, which is generally true in a system of systems, one day they may share information, the next day they may not, depending on their own objectives. So it gets really funky here when we see this in action. And then there are a couple of other areas. Keep in mind, if you are a system of systems engineer, remember, you don't have control over the development, the engineering of the constituent systems. You might have influence, but you don't control that unless you are in a what is called a directed system of systems. So in that case, a primary responsibility of a system of systems engineer is to develop the infrastructure which facilitates system to system interactions. Well, what if that infrastructure itself changes and in some cases even is abandoned? So what we've got are some very difficult challenges here, and it's not easy. So how do we develop? What are the aspects of an architecture framework that need to be included in order to actually architect a true system of systems? So once I was able to pull all this together, I then said, okay, let me try to develop aspects of an architecture framework. So a couple of points I want to make, maybe caveats, if you will. I'm not trying to develop a new architecture framework. In fact, I prefer not. I don't want to compete with DODAF. I don't want to compete with FEAF or TOGAF or UAF, et cetera. Those things have decades and millions of dollars behind them. I'm one person doing some research largely on my own time. At first, to help me get a doctorate degree. Secondly, just because I'm passionate about the topic and I see some deficiencies in my day job that I could help. So I'm not trying to develop a new architecture framework. I'm trying to understand what aspects need to be included. Now, whether we can implement those aspects in extensions to existing frameworks, awesome. Awesome. I would be thrilled. So I'll present the aspects of the architecture framework. So in getting at that, how do you do that? Well, I'm a systems engineer. We start with requirements. So what I did is I looked at all the architecture frameworks that are available. I looked at the ones that were tailored or customized for particular domains. So the healthcare, the Department of Energy framework, and all the rest of them, transportation frameworks that I was able to discover, where the architects slash systems engineers had to at least customize, if not downright create a new framework to be able to architect their system of systems. So I was able to identify a series of requirements. You may not be able to read this, and that's okay. I'm not going to go through all of them. I developed 17 requirements that if you want, and the way to think of this is if somebody wants me to use their architecture framework to help me engineer a system of systems, then that architecture framework has to satisfy these 17 requirements. Where did I get these? I got these from all of the efforts over the last 20 years of trying to customize or even create a framework to represent a particular domain's system of systems. That's where I got it from. So even if you can't read the actual requirements list on the right-hand side, some of the perspectives and attributes are listed on the left. And they're consistent with what I've shown already. So I'm an engineer, I'm a systems engineer. I start with requirements, which were based on stakeholder needs. So I'm following the systems engineering method. Once I was able to do this, then I went through systems engineering processes, and I was able to then identify different aspects of an architecture framework that would be needed. Now, it is comprehensive because, again, I pulled all these domains in. Also did full literature search. I mean, I have all of that as well. And I was able to come up with 5 different viewpoints or aspects or perspectives that if you want to develop a framework that will facilitate the development of an architecture at the system of systems level, then you will need at least a subset of these. So it's not intended to say, oh, DODAF has to go out now and create all these new viewpoints and views. No, that's not what I'm doing. In fact, some of these, a lot of these, which I defined, could in fact be implemented in FEAF, in UAF, in DODAF, MODAF, in TOGAF, the Open Groups Framework, and all the other major frameworks. So again, I'm not trying to create my own, and I don't want to create a new one. But all that said, these are some of the aspects that need to be included. And again, every system of systems is different. So when you start out to create a system of systems architecture, you may not need all of these perspectives or views. And I'll go through quickly what some of these are. So one of the first aspects is a total governance. Now, if you're familiar with system of systems and you've got an interest in that area, you will probably remember Mark Mayer's description of the 4 general types. In fact, Mark Mayer and others put together these 4 general types. They are directed, acknowledged, collaborative, and virtual. Each one is very different from the other. So again, depending on the type of system of systems you're dealing with, you may not need all of these. In terms of the governance piece, depending on the type, you may have a directed system of systems, which traditionally or typically has a very centralized, authoritarian perspective on engineering the system of systems. But then if you go to the other end of the spectrum, the virtual system of systems, there is no system of systems governance. So all of this information on this slide doesn't make any sense at all to architect and engineer a virtual system of systems. So it depends. There's a gamut, there's a spectrum that we have. But one of the areas that we saw, or that I saw in architecting and engineering a system of systems, is to understand the decisions, the goals, the authorities that are all wrapped up in a system of systems operation. In fact, I will say this. Now, this is just my experience, so you clearly may disagree with me. I'm okay with that. I don't mind. One of the areas that we don't do well when we are architecting and engineering just traditional single systems, I personally wish we paid more attention to decisions. What are the decisions that need to be made, both within our system as well as external to our system, but which our system contributes to? This is an area that I'm working on, again, in my day job. We're helping, one of the areas projects, we're helping Health and Human Services understand their data architecture. And one of the areas that we're trying to look at are, well, what decisions need to be made? And then what information and data are needed to make informed decisions? A lot of organizations don't think that way. They don't think in terms of, oh, wait a minute, you want me to list the decisions that I need to make and how a system will contribute to that? Well, in a system of systems, all kinds of decisions are made, both at a single system level and broader. Think of a smart grid. Think of an electrical grid. That's a true system of systems. Very dynamic. Nobody owns it. The US government does not own the US power grid. A lot of people own parts of it. The US government regulates it very heavily, in fact, but they don't own it. So what decisions need to be made and who makes them and what information is needed? So just thinking from one perspective, decisions can help us understand, all right, how do all these things integrate together or need to be integrated together? Also in system of systems, individual systems may have very different goals and objectives, and they will only participate if it's a voluntary situation, if their strategic objectives can be met. So all of this is very dynamic. So if I'm going to represent a system of systems, I need these perspectives. Maybe not all of them, but I certainly need to start thinking about it. The second area is relationships. In a single system, when you're the systems engineer, you define the relationships between the subsystems and the components. That's part of engineering. You define these, you constrain them, you identify the interfaces between components and subsystems. They're very structured. If I can pull you up to the system of systems level, no, they're not. These relationships can be very dynamic. They come and they go. They change, all depending on the environment, the situation, and individual system objectives and goals. So we need to capture that somehow. Now, I can use some traditional systems engineering tools. We've got pairwise comparison technologies out there and methods. I can use some of those. I can use things from mathematical set theory, but not to bore you, to talk about bringing in common behaviors and social interactions, etc. So I can do some of that with the tools that we have. But it's very difficult to bring this into a behavioral concept, because now again, if I'm the engineer, system of systems engineer, I'm engineering the infrastructure that will facilitate these relationships between the systems. If I don't understand these relationships, how can I develop an infrastructure that facilitates these relationships? It's hard. So I introduced this viewpoint to bring in those relationships. As I mentioned, one of the primary responsibilities of a system of systems engineer is to develop the infrastructure that enables the interactions between systems. And so I need to be able to do that. I can represent some of these very well with the tools that we have. That's good. But I also have some challenges as well. If I have two systems that I can control, then I can put interoperability standards and constraints on both of my systems so that they can interact successfully. All right. Well, what if I can't do that? What if I don't have control? I may have influence, like a collaborative system of systems. You set a set of standards, you establish a set of standards. Think the internet as an example. All right. If I want to play on the internet, I'm going to adhere to certain protocols and standards, or I'm not playing on the internet. If I want to develop an internet-based application, I better know the standards and the protocols, or else it's not going to be able to run. Okay, that's a part of it. But now, is this infrastructure going to be static, or does itself need to change? So a lot of questions need to be answered. And ultimately, what if two systems join the system of systems and they're not completely interoperability? Is there anything I can do as the engineer in my infrastructure to either assist or possibly enable two systems that were not built to operate together to operate together? The resource viewpoint, this is another area because of the dynamic nature. Most architecture frameworks represent resource flow in some way, and that's great. Where they fall down on, as I mentioned in my earlier example with the OV2. So where they fall down on is, well, what if the state of resource flow and interactions, transportation, et cetera, changes over time? It's not static. How do you engineer that? So that becomes a major issue. And then the last area, which I need my framework to represent adequately, is specifically focusing on information. One of the most critical resources in a system of systems is information. Systems interact in part by sharing and exchanging information. So again, as the engineer, how do we make that happen? How do we create an environment and understand what is needed? So we need to start thinking at this from a slightly different perspective, from a traditional systems engineering. Now I'm thinking, all right, where does certain information need to be at specific times? That ties back to decision making. It ties back to activities. Systems need information, among other resources, but information is so critical. They need information. They also need to understand the attributes of that information, its reliability, its quality. They need, and other things like timeliness. So now we need to start addressing those in much further detail that we've done. And also, by the way, this is a dynamic situation. So those are the areas that I found, both in my own experience working as a systems engineer, dealing with integrating systems, engineering true system of systems, as well as what I've found in other domains. These are the aspects that need to be incorporated in some way or form. And like I said, I don't care if you want to extend existing frameworks. If you want to create your own, it doesn't, that's not my purpose. But these are the kind of things I need to truly architect a system of systems. So the last thing I needed to do was some verification. Great. I've just outlined a number of views and models and concepts that need to be in a framework to properly represent system of systems development. So I did go about trying to do a verification. Number one, traceability to requirements. That's systems engineering 101. I did that. I had all of this data, all the information on existing architectures that were customized or created from scratch in order to represent a certain domain. So I can go back now and I can compare my framework characteristics to their architectures. Could I use these extensions in their projects? And then lastly, I did a case study. So let me show you real quick because I'm wrapping up and I'm running out of time. So I trace back to requirements, simple traceability matrix, and I used all of the principles applied. I wanted to make sure that every requirement was covered by at least one perspective or view or model, and then vice versa. I wanted to make sure all my requirements were covered. I also took a look at existing architectures. This is a power grid or the Department of Energy architecture. I was able to represent their aspects. This is a customized architecture that they created with their viewpoints. And they didn't use every single, or they would not need to use every single aspect that I defined. You can see as an example, a state definition and transition. That was not a part of what they did in their architecting. That's okay. But I was able to represent their architecture using the aspects of the framework concept. And then lastly, I did a case study and I was looking at the Tampa Hillsborough County Connected Vehicle Pilot Program. I ultimately will be retiring in Central Florida. And so this was near and dear to my heart. And fortunately, a lot of information is available. There was an architecture for this pilot program. It is under the Department of Transportation. Their architecture included an enterprise view, functional view, physical view, and a communications view. Those are the four, they called them views, that you could think of these as viewpoints. So what I did is I said, hey, can I create their products using my definitions? And here's just two examples. I was actually able to reproduce some of their views using the products I defined in the architecture framework concepts. And then I used very simple, this is not complex, so it's nothing to write home about. I used NetLogo. It is a simulation tool that you can use that represents certain dynamic interactions between systems. So you can see here, I overlaid a grid onto the downtown Tampa area. These were all defined in the pilot program. So there were traffic lights and traffic signs and a number of different systems that were incorporated in this pilot program, including cars. You could voluntarily join this pilot program and you would need to have something installed in your car. And surprisingly, there were thousands of people who volunteered for the pilot program, which was pretty gutsy because it means the city of Tampa now can track you, or rather track your car anywhere as long as it's within the Tampa area. Then the city government can track your location. So, a lot of people it was a lot of courage to do that. Anyway, I converted the downtown smart traffic grid into a NetLogo grid and then ran some data. This is one metric. This happens to be delay time in minutes for a typical commute under a whole bunch of conditions. This is one of many different cases that I was able to represent. And so the actual data that was collected is up on top. My modeled data is down at the bottom. It's not perfect. I get it. I'm okay with that. So I can't say this is, this, oh yeah, this verified. My stuff is completely verified. I'm not going to be so brave to do that, or foolish rather, to do that. All right. So to finish up, I asked some pretty interesting questions. Does a common framework exist today? No, it doesn't. Has or have people been able to extend architecture frameworks? There's no evidence of any successful extension to the system of systems level. And then I turned that question around and I said, well, can it? Can I take, I looked at like the big 8 architecture frameworks, and the answer is no. None of them adequately represent the dynamic behavior. So that's when I started to look at, all right, what are the common characteristics then that need to be in? What aspects will enable the translation? And then ultimately, once the framework is developed, can I represent a domain? And the answer is yes, but with caveats. All right. So interesting, at least for me anyway, it was interesting work that we had, but I was able to do a bunch. Obviously, further work is needed, as is always the case with this. All right. So, and that's it. So I just wanted to share this. I would love to hear your experiences, even if I realize we'll run out of time tonight. I'm willing to stay on for a while, though. Does anybody have any questions or share your experience in this area? If you've done some of this work too in your day job or in research. Joseph, go ahead.
Well, I'd much rather hear other people's questions, but I have 4 question points
Mhm.
I would like to just mention to you. One, when you somewhere in the middle of the talk, you said you're a systems engineer and you start with requirements.
Mhm.
I'm a systems engineer and I don't start with requirements. I start with understanding the problem.
Mhm.
I noticed in your talk, in your discussion about decisions and needing to make decisions, I'd like to point you to Bruce Lerner, who has been doing some work in that area and has been developing some tools.
Cool.
And I'll put you in touch with him, or I'll put him in touch with you. Or you can meet him on Thursdays, 7 p.m. New York time online. And I'll share the URL after we get through talking. We,
Excellent.
we get
Thank you. Yeah.
we get together and talk on Thursdays at 7 p.m. New York time. The other thing is, in all this systems of systems stuff, my research, when I first looked into it all those years ago when it first started, said this is exactly what operations research does. And I have never ever heard anybody in system of systems engineering in INCOSE mention the word or the words operations research.
I look at operations research as a very valuable tool. I would not say that, I wouldn't agree with a statement like system of systems engineering is the same as operations research, but I'm fully on board to say that operations research is an extremely valuable tool for this. The reason being is that think of what operations research is. It is examining the operations of either a system or a collection of systems or an environment or a situation, a mission, etc. And absolutely that is and can be invaluable. So I don't argue, certainly will not argue with that.
Back in the 50 years ago, the difference between OR and systems engineering was systems engineers build systems from scratch.
Mhm.
OR takes existing systems and makes them work together. And it seems that INCOSE Systems of Systems does a hybrid. It tries to build some aspects of the system of systems and use other aspects of the system of systems. But
Mhm.
there should be a lot of information in OR that would help you.
Mhm.
And I don't know whether they have frameworks or not, but it would be an additional resource area.
Very valuable. Good point.
And my last comment was, and I need to share my screen to show you this,
Sure.
but you worked with an awful lot of frameworks, architecture frameworks, and I wondered if you'd actually plotted them in a meta framework to see what aspects of system complexity they cover with. And the host has disabled participant sharing, screen sharing. So if the host would allow me to share
Mhm.
for a moment.
Uh, there we go. You should be able to share.
Okay. This is something I use in my teaching. It's based on Derek Kitchen's 5 layers of system, or we upgraded it to system complexity, and the system lifecycle. And you can see that traditionally INCOSE deals at level 2, single systems,
Right.
and ignore the circle about the requirements block because that's the
Mhm.
I give the background to the system development process in my course, and this came right out of the course requirement state.
Mhm.
So his business level is what INCOSE calls systems of systems. But then as you
Mhm.
go up in complexity, I wondered if some useful information would come out by looking at the different architecture frameworks and seeing where they fit in something like this.
Interesting. So I did some of that, and that would correspond to roughly your levels 2 and 3. But
Mm-hmm.
I did not go through the full gamut of your 7 levels of complexity. And I think that would be a very good idea to look at some of the meta architecture concepts that could be extracted. So
Might be
I think
might
that's
be
a good point.
might be a paper for next year's symposium.
Right. I think that would be extremely valuable and quite interesting to undertake. I like that idea. Mhm.
Okay. Well, thank you, and I'll now turn it back to the chairman.
Great. Thank you, Joseph. Good points, one and all. Any other questions or comments or experiences? I would love to hear if you have other experiences, either now, tonight, or offline. Please feel free to contact me through INCOSE.
This cast, I did type one up, but it may have been overwhelmed. Uh, I guess I was curious when I've been using UAF recent history,
Mhm.
and that seems to, in a way, have deprecated DODAF and MODAF and NAF and a few, maybe even a few others. In other words, formed the UPDM, and then so
Mhm.
I'm looking at it going, I'm not going to talk maybe in DODAF terms anymore, only because I'm trying to use the latest and greatest. Does that mean that some of those other ones that you say there's 150, but have any others been in a sense like deprecated, saying that okay, UAF is on the tip of the spear for those 4 or 5 other frameworks? Would
And
that
the answer
reduce
is
down?
yes. Yeah.
Oh, okay, all right.
Absolutely. So there have been several cases in which frameworks were created, used, and then merged. And
Yeah,
there's even others that were basically superseded
okay.
by, like you said, by
Yeah,
newer versions, like the Unified Architecture Framework. Could easily be thought of as a reason to retire a number of architecture frameworks.
Okay.
And in fact, I think I've heard people say that, you know, oh, well, UAF, the Universal Architecture Framework, is supposed to overtake at some point, you know, all of the other frameworks. But that's just anecdotal.
Can I add something to it, Steve?
Yes, Risa,
Because I
please.
have this is my you're harping into one of my areas of experience, which is system architecture tools.
Mhm.
So my understanding with UAF is that it's supposed to be they were supposed to try to take the best aspects of a lot of these frameworks and merge it together to produce something better. And what they ended up doing is they ended up taking a lot of the existing viewpoints in current frameworks and kind of mix and matching them to be what is described to me as like the best of breed. And so there's some very interesting things that go on in UAF because it's not, you can think of it as not like, oh, it's supposed to be the architecture framework that like goes over like all architecture frameworks. Yeah, but it also has the weird qualities of like DODAF and MODAF and kind of mesh them together appropriately. Um, some things to think about. So remember that UAF is the architecture framework. If you're using a modeling tool, there's something called Unified Architecture Framework Profile, UAFP.
Mhm.
And the translation of that in an architectural tool means that the language is different, but UAF in certain tools, Cameo, for example, has the ability to basically label some of the diagrams in like the DODAF or NAF or MODAF labels, right?
Mhm.
The other thing that's been interesting too is, like, because like my biggest thing to you, Steve, is more of the whole like, a lot of these architecture frameworks are static in nature. So the hard challenge, and I think this is where SysML2 is trying to go with parts of it, but I don't know how well it's going to execute some of it, is how do you describe phasing between diagrams? Because a lot of this is, oh, I can define at a given point in time, this is what the system is, not just system to system, but what the system is. But if it evolves to, let's say, a newer version, even then, it's not really accounted for outside of redrawing the diagram. So there is things like capability phasing in UAF. I forget which like equivalent stuff it is. It used to be like I think it was like CV3 and like SV8 in
Mhm.
like DODAF, right? But I think the hardest thing about some of these tools is that they, at the end of the day, they only describe what is effectively a structural diagram in a snapshot of time. And supposedly there's supposed to be features within things like SysML2 to kind of help for some of that later down the line. But I haven't really seen something where people have really addressed this capability phasing part in the language. So, yeah.
Outstanding, and I couldn't agree more. By the way, I'm waiting with bated breath for SysML2, to formally come out. I've only read snippets of it so far, but that, Risa, you bring up a great point in that. Think about this for a minute. Model-based systems engineering should solve a lot of the problems that I've seen with the dynamic nature. In other words, if I can take a view, whether it's an OV2 or, pick your favorite view from any architecture framework. If I'm not restricted to create a static diagram for that view, then I can incorporate the dynamic nature. In other words, if I can build, instead of a pay-per-view, not pay per view, but a paper, PAPER view of an aspect like an operational view or like a resource flow perspective, then if I can put that into a simulation construct, then I can represent the dynamic nature. And so, and model-based systems engineering ultimately are ideally, and by the way, there are some here tonight. Reese is one of them that quite honestly can run rings around me on discussing model-based systems engineering. But if the model is the ground truth, is the, the ultimate authority of truth, then I can overcome a lot of these challenges because I'm not restricted to a diagram depiction of resource flow. It can be represented in a true mathematical or logical model that is then implemented in a simulation environment. And so most of these challenges would be overcome. And honestly, that kind of, convinces me if we can continue to progress and evolve toward true model-based systems engineering, there won't be a need for, all of my little system architecture views that need to be incorporated. So I'm really hoping. Unfortunately, what I see in my day job, in my experience, is most people think of MBSE as having a tool so that I can write a diagram or draw a diagram. And yeah, it'll keep track of consistencies and traceabilities and stuff for me, which is all good, right? Tools like Cameo do that for me. That's great. But I'm still drawing static diagrams. And I think, and Risa, correct me if I'm wrong, I think what the ideal version of MBSE is, no, we get away from static diagramming. And now we get into interactive diagramming, whatever that means. Am I onto something or am I all wet here?
Oh, you're talking to, like, this is the conversation I've had with not just the Cameo audience, but also, like, I have a couple of contacts in another tool vendor who are thinking similar mindset. Um, so the thing that has advanced on the Cameo side is there's a lot of architecture simulation as now a thing that you can do.
Mm-hmm.
And my thing about the architecture simulation is you're often trading the descriptive nature of the diagram
Mm-hmm.
to make it run in the simulation.
Mm-hmm.
And so sometimes you're losing a certain level of traceability when you do that, because now you have to encapsulate some parts of the functionality in code for it to work. And therefore, it's not, you're not conveying what you functionally want. You're now conveying, people overdo it because then they start trying to recode some of their simulation tools in Cameo. And that becomes a mess on its own. And then there's other aspects of that too, because remember that sometimes for the purposes of descriptive architecting, we may be very descriptive for the purposes of the diagram and to communicate our design. But later on the line, we may want to, when we choose to implement the module in code, for example, there's certain tools that enable us to swap out that box and test it against something like almost like an S-will, where you're trying to test the actual code itself, right? So there is talk of that. I think the hard part about that is, what is that balance when you're at the appropriate level of the life cycle? Because there is a reason why we write so many freaking diagrams. It's so that way we can communicate what the design is. But when we shortcut it with simulation, you can do it, but I feel like those people tend to forget that they lose part of some of the no-go cases, some of the like the range in which the behavior can be described for the purpose of communication. And that's the challenge that I think is happening with some of the tools right now. They want to get into the space, but they don't, finding that balance outside of a more stringent framework or standard has been challenging.
I agree. Yeah, I've seen some of that same kind of thing, and it's not a knock on the tools. The tools are evolving, and I think in general, I think they're going in the right direction. But we have a long way to go. We have a long way to go. I hope I live to see when true model-based systems engineering is truly implemented in what I think it is or what it's supposed to be. But I don't know. I'm starting to get up there in age. I don't know if I'll live to see it, but But some of you younger folk, I truly will be optimistic and say, yeah, you'll see it. You'll see it. Very cool. All right. Any others? I know I'm over the time, and I do appreciate your patience and sticking with us. Any other comments that you want to bring out or questions?
Steve, this is Mike. If it's okay, I took screenshots of your slides tonight and put them in a PDF in case anybody wants to see them right away, and I uploaded them in the chat.
Oh, great. Thank you, Mike. I appreciate that. That was nice. I'm willing to share, by the way, the slides to anyone. So, but I appreciate you doing that because, yeah, it would take me some time to PDF and all that good stuff. So thank you. Thanks, Mike.
Yeah, I think typically what we would do, I think we present the slide deck and post that alongside the YouTube, presentation when it finally gets wrapped up.
Right, but I believe so.
I know we sometimes have done that in the past. So
yeah, that's how it's just historically done. Yep, and we're gonna look into SlideShare. Okay. So we'll be collecting your stuff, Steve, and getting it out to the world.
Great. And Dan,
probably
just
through SlideShare and Yammer. Over.
Perfect. Just for your information, it is on Basecamp. These slides in PowerPoint version are on Basecamp. So, all right, great. Well, thank you very much, everybody. I'm looking for Michael, but I think he had to head out. So, does anybody want to wrap things up?
I have one comment.
Go ahead, Joseph.
The conversation earlier between you and Risa, you're talking at different levels of abstraction. And so the work that we're doing in object-oriented systems engineering goes a lot past MBSE. And I put a link to that and a presentation about a year ago that shows what we're looking at and the capabilities of it. And so you have different levels of abstraction. And so if you're interested in the code to do one part that's static, that's fine. You want to look at the dynamic area, that's fine too. You just use a different set of data out of the underlying database. You don't have to use all the data in every single view.
Fair point. Yeah, good point to bring up. And by the way,
Thank you, Steve.
Excellent. Well, thank you, everybody. I appreciate attending and a great discussion afterwards.
Yeah.